Hello, I'm Maciej Janicki from the Human Science Computing Interaction Research Group, and in this video I'm going to give you a short introduction to data mining. By the term data mining, we mean a set of computational methods aiming at extracting knowledge from data. The data could be any information that is available in digital form in large masses. For example, websites, server logs, shopping transactions, sensor measurements, or, more in the humanities context, books or library catalogs. However, like natural resources buried in the ground, the interesting information contained in the data is buried in a mass of irrelevant details, random noise and opaque data structures. It thus needs to be mined, meaning extracted from its surroundings, purified and distilled in many stages. A data mining workflow typically consists of two stages: pre-processing and analysis. The pre-processing stage amounts to reducing the data to contain only information relevant for our analysis, presented in a clean form. Typically, though not always, the data structure that we aim at is a table. The rows of the table are called observations and correspond to a single item of our data, like a book, a transaction, a measurement, while the columns are called features or attributes, and correspond each to a single aspect of the observation that we want to capture. In this example, the data is a metadata catalog of the Dutch Royal Library, with each observation representing a publication, described by attributes such as author, title, publication year, etc. Pre-processing typically involves at least the following steps: feature extraction, in which we extract the observations and their feature values from raw data in whatever format; data cleaning, dealing with missing and incorrect values and removing irrelevant observation; feature selection, automatically choosing the features most informative for the target analysis and discarding the rest. In the analysis phase, we convert the data to knowledge using methods from statistics and machine learning. The four classical tasks for data mining are clustering, outlier detection, classification, and association pattern mining. Clustering means identifying groups of similar observation. It involves defining a similarity or distance metric on pairs of observations and then dividing the dataset into groups so that the observations within each group are close to each other. Related to clustering is the problem of outlier detection, detecting observations that are strikingly different from others, so that they can represent some interesting event or anomaly. Classification is similar to clustering in that it divides observations into groups. However, in this case, we have a set of training data for which the class is known, and we learn to generalize the relationship between the class and other attributes so that we can classify further observations. Finally, the problem of association pattern mining is about finding similarities between columns, that is, dependency relationships between attributes. A classical commercial application of this is finding groups of items that are frequently bought together. But, going back to our library catalog example, we could mine association patterns of genres to discover that, for example, the labels state publications and public and social administration often occur together. If you're interested in data mining, there's plenty of books and learning materials on this topic. As a comprehensive theoretical introduction, I recommend the Springer textbook by Charu Agarwal, which is available through our university library. The recommended programming language for data mining is R, so if you want to try out the methods in practice, you can have a look at one of the many books on data mining in R, for example this freely available book by Yan-Chang Chao. That's it for this video. Bye and see you at the university.